Imagine a cosmic clock governing the spark of life itself. For decades, scientists believed young stars were violent, chaotic engines, blasting their newborn planets with sterilizing radiation for up to 20 million years. But a recent breakthrough from NASA has just shattered that timeline. What if the most destructive phase of a star's youth is actually a brief passing storm? What if the universe is prepped for life millions of years earlier than we ever thought? Welcome to a fundamental shift in our understanding of stellar evolution. Recent analysis using archival data from the Chandra X-ray Observatory looked closely at young stars, specifically those with masses similar to our own sun. The findings are staggering. Young stars experience what scientists are now calling early dimming. Instead of a gradual, drawn-out decay of intense X-ray and extreme ultraviolet radiation, these stars power down their high-energy emissions abruptly. At a given age, these sun-like stars emit only a quarter to a third of the expected X-ray flux. Why does this happen? It comes down to rotation and magnetic fields. A young star spins rapidly, acting like a giant dynamo that generates powerful magnetic fields and intense X-ray flares. As the star ages, it projects stellar winds. These winds act like a brake. They carry away angular momentum, causing the star to spin slower. A slower spin means a weaker dynamo, fewer flares, and a cooler corona. Furthermore, as stars mature, their internal structure shifts. They develop a radiative core, which alters the convection zone and further dampens the magnetic dynamo. This combination causes the star to burn out its energetic youth incredibly fast. This early dimming is the ultimate lottery win for orbiting planets. High-energy X-ray and ultraviolet radiation is the primary destroyer of planetary atmospheres. It heats the upper atmosphere of a young planet, causing essential gases and water vapor to expand and boil away into space. Under the old models, an Earth-like planet would endure this stripping effect for 20 million years. Many would never recover. But the early dimming model compresses this stormy phase. The radiation pressure drops sooner. Planets get a crucial head start. They can retain their atmospheres, cool down, and stabilize. Liquid water can pool on the surface. The window for habitability opens up millions of years earlier. This changes how we look at our own history. The early Earth likely faced a shorter barrage of radiation than we once calculated, aiding the preservation of our oceans. However, the story is still unfolding for M dwarfs, the most common stars in the Milky Way. These smaller stars are notorious for relentless, long-lasting flares. Scientists are now investigating if these stars also experience a rapid drop in activity. If they do, the number of potentially habitable worlds in our galaxy will skyrocket. Yet, a critical data gap remains. Only 2% of prime target stars for NASA's upcoming Habitable Worlds Observatory have complete data across all crucial ultraviolet and X-ray bands. To solve this, new missions like MANTIS in 2027 and UVEX in 2030 will launch to map these stellar environments in unprecedented detail. The cosmos is dynamic, and our understanding is evolving right alongside it. The early dimming star is proof that the universe might be far more welcoming to life than we ever dared to imagine.